Welcome to episode 2 of the AI powered Ethical Hacking Mastery 2026 series. In this episode, we're diving into AI plus network reconnaissance supercharged. You'll learn how artificial intelligence transforms traditional network scanning into faster, smarter, and more actionable intelligence, just like modern red team and penetration testers do in 2026. We will learn network reconnaissance in two ways, using manual techniques and using AI-powered methods. Before learning network reconnaissance, we first need to understand what reconnaissance actually means, what a network is, and how ports and services work. These are the fundamental building blocks. Without understanding them, network reconnaissance won't make sense. Once these basics are clear, everything that comes next becomes much easier to learn and apply. Reconnaissance means thinking about the target before attacking. It's about understanding where the doors are open, where the walls are strong, and where the risks exist before any action is taken. Network. In this image, what you're seeing is that every device has its own unique digital address. This digital address is called an IP address. Just like a letter can't be delivered without a home address, data cannot reach any device without an IP address. An IP address tells the network who is where. It identifies every device and shows its exact position inside the network. Private IP and public IP. Here we see two different worlds of IP addresses. On the left is the private IP. It works only inside your home or office network. On the right is the public IP. This is what the entire internet can see. Your mobile or laptop isn't directly visible on the internet. The router uses a single public IP to connect everyone inside your network. This process is called NAT network address translation. Networks can basically be divided into two types, internal networks and external networks. An internal network is a restricted, private environment, such as a home, office, or an organization's own network, where only authorized devices can connect and exchange data at high speed. It's mainly used for local resource sharing, file transfers, and internal communication. On the other hand, an external network usually refers to the internet or public networks, which provide global connectivity and can be accessed by anyone. Although it is relatively slower and less secure, it offers unlimited opportunities for communication and data exchange with any part of the world. In simple terms, an internal network is a connection within a private world, while an external network is a public medium for global communication. LAN, WAN, and the Internet. There are three fundamental layers of networking. LAN, or Local Area Network, covers a limited geographic area, such as a home, office, or campus. It provides high-speed connectivity among devices and is usually under private or institutional control. WAN, or Wide Area Network, connects multiple LANs over larger distances, like different cities or countries. It is often managed by telecommunication providers and has slower speeds compared to LAN. Finally, the Internet is a global network of networks, linking millions of private, public, academic, and government networks via the TCP/IP protocol suite. This enables access to information and services anywhere in the world. In simple terms, LAN is for local connections, WAN covers broader areas, and the Internet provides global connectivity. Ports concept. Think of an IP address as a building, but a building has multiple doors, right? These are called ports. For example, port 80 is for the web, port 22 is for SSH, port 443 is for secure web, HTTPS. Without an IP, there's no building, and without a port, there's no way in. Now we're going to understand two very important things, TCP and UDP. In network reconnaissance, if you don't know the difference between these two, you might make wrong decisions. TCP stands for reliable communication. Before sending data, both sides perform a handshake. This means you get confirmation that the data reached correctly and whether any packets were lost. Because of this, TCP is a bit slower but much more secure. Protocols like SSH, HTTP, and HTTPS all use TCP. UDP is exactly the opposite. There's no handshake and no confirmation. Once the data is sent, no one checks if it actually arrived. This makes UDP very fast, but there's a risk of data loss. Protocols like DNS live video streaming, and online gaming use UDP. TCP means reliable delivery, while UDP means fast delivery. When doing reconnaissance, if we see an open port, we need to know, is it TCP or UDP? With TCP, getting service details is easier, but with UDP, scanning becomes much more challenging. Before starting network reconnaissance, the most important concept to understand is passive reconnaissance versus active reconnaissance. If you don't understand this difference, both AI-based scans and manual scans can easily be done the wrong way. Passive reconnaissance means collecting information about a target without any direct contact. Here, we only observe. Examples include Google searches, Shodan, social media, and WHOIS lookups. The target doesn't know you're gathering information, so the risk is very low. This approach is called OSINT, Open Source Intelligence. Active reconnaissance is the exact opposite. Here we send direct packets, probe services, and perform port scans. Examples include tools like Nmap, HPing3, and MassScan. Because the target can detect this activity, the risk is much higher. However, active recon provides detailed information that passive methods simply can't reveal. During reconnaissance, you must decide when to stay passive and when to go active. Wrong timing or excessive scanning can easily lead to detection. Manual recon versus AI recon. On the left, what you're seeing is manual reconnaissance. There's a lot of output, but making decisions is difficult. On the right, AI analyzes all the data and clearly tells you what matters and what should be tested first. AI doesn't hack for you. AI teaches you how to think. Manual reconnaissance is a traditional approach where a security researcher or penetration tester manually uses different tools to scan a target system, analyze the results, and assess risks based on personal experience. This process is time-consuming, prone to human error, and becomes especially challenging when dealing with large-scale networks that require full coverage. In contrast, AI-driven reconnaissance uses artificial intelligence and machine learning algorithms to automatically collect and analyze data, identify vulnerabilities, and prioritize risks. AI can scan thousands of services in seconds, correlate findings with historical data and threat intelligence, reduce false positives, and even detect emerging threats through predictive analysis. However, while AI is fast and highly scalable, it still cannot replace human contextual understanding and creative problem solving. That's why modern cybersecurity relies on a hybrid model where AI handles initial scanning and data processing, and humans make the strategic decisions. This human AI collaboration is considered the most effective approach in today's cybersecurity landscape. Attack surface means how many openings a system exposes. The more entry points a system leaves open, the larger its attack surface becomes. A hacker doesn't go everywhere. They go where the system is weak. Disclaimer: this content is for educational and ethical hacking purposes only. Do not attempt to scan, hack, or access systems without explicit permission. Always use your own testing environments or authorized targets. First, we start with passive reconnaissance. You use passive recon at the beginning, especially when you want to stay stealthy. Here, information is collected from public sources only. The chance of being detected is very low because there is no direct connection to the target. In this phase, we use multiple search engines, such as Google, Bing, and DuckDuckGo, along with several other search platforms. ExploitDB Google Hacking Database, also known as GHDB, is a collection of search engine dorks. These are specially crafted Google search queries designed to discover hidden, sensitive, or potentially dangerous information on websites. Shodan is a search engine for the internet, but not for websites like Google. It's designed to search for internet-connected devices. Shodan can find servers, routers, webcams, traffic lights, power plants, and almost any IoT device exposed to the internet. DNS Dumpster is a free online DNS reconnaissance tool that collects DNS information about a domain and presents it in a visual map. It's essentially a web-based version of the popular reconnaissance tool Recon NG, widely used by security researchers and hackers. Its main purpose is to collect all public DNS records of a target domain, identify hidden or forgotten subdomains, and present the results as a visual network topology map or diagram. This helps security researchers, ethical hackers, and penetration testers during the initial information gathering phase, allowing them to understand which servers, mail systems, hosting providers, and overall attack surface are exposed to the internet. Webmasters can also use this tool to review their own domain security configuration and check for unnecessary or unintended exposure. Wayback Machine, also known as archive.org, is a digital time capsule, a digital library of the internet's history. Since 1996, it has stored millions of snapshots of websites from around the world. Its main purpose is to preserve historical versions of websites, allowing users to go back to any date and see how a web page looked at that time. This makes it an extremely valuable tool for researchers, journalists, lawyers, and students, as it can be used to recover deleted or changed content, verify information, and collect digital evidence. Security analysts and ethical hackers also use the Wayback Machine to discover sensitive information in older website versions, such as hidden directories, outdated configuration files, or discontinued APIs, and to analyze a target's digital footprint over time. Simply put, the Wayback Machine is a massive memory bank of the internet, preserving the past for use in the present. Census is an internet-wide search engine and security monitoring platform that continuously scans the entire internet to collect real-time data about publicly accessible devices, servers, and network systems. Its primary purpose is to build a massive database of SSL/TLS certificates, open ports, running services, and software versions, allowing users to analyze the digital attack surface of any IP address, domain, or organization. Security researchers, ethical hackers, and network administrators use Census to identify weak configurations, discover new subdomains, and ensure proactive defense against cyber threats. Census works similarly to Shodan, but it places a strong emphasis on certificate transparency logs and encryption-related intelligence, making it especially powerful for TLS and certificate-based reconnaissance. Whois.domaintools.com is a professional threat intelligence and research platform designed for cybersecurity professionals and investigators. It provides not only current WHOIS data, but also historical WHOIS records, historical screenshots, related domains, and in-depth security analysis. Whois.com/Whois is a simple and fast WHOIS lookup service that anyone can use. It's mainly used to check basic domain ownership details, registration dates, and domain availability, and is often integrated with domain registration services. Namecheap.com/domain/Whois is a tool provided by the Namecheap domain registrar. Along with free information, it allows users to purchase domains, add privacy protection, and manage domains directly as part of their customer service ecosystem. Open Corporates is the largest open database of companies and business entities in the world. It operates as a public benefit organization, collecting, aggregating, and making available corporate data from official government registries across the globe. Passive reconnaissance can be done in many more ways. What we're showing here is just to give you an idea. Some information can also be discovered using Google Dorks. In the past, a lot more data was exposed this way, but today, most organizations have secured their websites, so finding sensitive information has become much harder. To make Google Dorks easier to understand, I've shown just a few basic examples. Google Dorking is a technique that uses Google's advanced search operators to find hidden, sensitive, or misconfigured files and information on websites. It works by combining specific keywords and operators to precisely filter search results. So far, I've given you a clear idea of passive reconnaissance. Now we're moving on to active reconnaissance. First, I'll show you how to do active recon manually using real commands and tools. Then, I'll show you how the same process becomes much easier with AI. This way, you'll understand both the manual technique and the AI-powered approach step by step. TCP Transmission Control Protocol works like a reliable human conversation. When you connect to a server, for example, when you visit a website, TCP first performs a 3-step handshake. Nmap is used to gather detailed information about a target system. Here's the command: nmap-p-t4-a-v192.168.0.1. In real-world usage, this command is helpful when you want to scan 1 to 65,535 TCP ports, maintain good speed, and get clear, detailed output. The -p- option means scan all ports automatically. This gives you a complete picture of the target's exposed services and attack surface. So in short, what do we get from this command? We can see which ports are open. We know which services are running. We can identify the service versions. We get an idea about the operating system. We can spot possible vulnerabilities at a basic level, and we can even understand the network route. That's why this single command is extremely powerful for network reconnaissance. I'm testing this only on my own router's IP address. Never test any website or system without proper permission. For practice purposes, I've added legal test links in the video description. These platforms allow testing and do not require special permission. Additionally, if you're using bug bounty platforms like HackerOne, BugCrowd, or Integrity, always check the scope first and perform testing strictly within the allowed scope. Ethical hacking means learning responsibly and testing legally. For a cleaner and more professional output, especially if you want to save the results, use this command: nmap-p-t4-a-v-onscan.txt_ip. This command saves your entire scan output into a file called scan.txt, so you can review it later or include it in reports. Now, use SGPT AI prompt. Simulate and analyze what an Nmap scan would reveal about testfire.net. Explain ports, services, OS detection, NSE results, and security implications from a defensive and learning perspective only. This allows us to understand Nmap results safely without scanning a real system ourselves. When prompted for execute permission, press E. If you run the AI tool with root privileges, you won't face any issues getting scan results. Otherwise, you may see messages like, "I can't assist with that." Short summary of the testfire.net Nmap scan. The host is up. 4 open TCP ports. All of these ports are running Apache Tomcat, which means it's a Java/JSP based web application. HTTPS is active on ports 443 and 8443, and a valid SSL certificate is in place. Ports 8080 and 8443 are considered sensitive or admin type ports, which means they increase the attack surface. Most of the remaining ports are filtered by a firewall. Operating system detection is unreliable because this is a virtualized lab environment. The network distance is 2 hops. From a security perspective, this is a training or demo web application with multiple web ports exposed, which is great for learning, but risky in a real production environment. I'll also test this using the Gemini CLI to see what kind of results it gives. Using root access usually works better, but it's completely your choice. If you don't get proper results, then try running it as root. I used the run shell command option and pasted the same prompt there. When you give a prompt to AI, you simply explain what you want to analyze. Based on that, the AI will automatically create the required commands, run the scan by itself, and analyze the results. However, to actually run the command, you must give the AI execute permission. When prompted, just press 1 to allow execution. Scan doesn't take much time. Compared to doing it manually, using AI takes significantly less time to get results. Here we can see some changes compared to the previous scan. Firewall looks strong, but the same web application is exposed on multiple ports. There's an older version of Tomcat, along with banner exposure and SSL misconfigurations, which would be risky in a production environment. Learning focus areas from this scan include Tomcat hardening, port minimization, banner hiding, proper SSLTS configuration. Here, Gemini CLI actually ran a real Nmap scan. SGPT usually performs simulation and analysis instead, so remember this key difference. AI analysis provided a lot of additional insights and information that would normally take much longer to figure out manually. Next, we perform an ICMP test, which is basically an advanced version of a ping. Using the command hping3-1testfire.net, we check if the target responds to ICMP requests and observe the latency, or how long the response takes. This helps us understand basic reachability and network responsiveness before deeper scans. Single TCP port response check, no flood, command hping3-s, P80-C3testfire.net. Here, we're checking whether port 80 is responding at the TCP level. Similarly, to observe firewall behavior for HTTPS, we check port 443 to see the TCP response pattern. We used SGPT with the prompt, simulate HPing3 style ICMP and TCP response analysis for testfire.net and explain firewall behavior. The AI analyzed how the target responds to ICMP and TCP probes, highlighting patterns in firewall filtering, response times, and which ports are open or blocked. This simulation helps us understand firewall behavior without actually sending packets to a live system. If you paste the same prompt into Gemini CLI, Gemini will automatically generate the required command, run the scan on its own, and show the results. After the scan is complete, Gemini CLI also provides a clear analysis of the findings. Now let's look at host discovery using Nmap. First, we run a basic ping scan to check whether the host is alive. Command Nmap SN 54.82.22.214. This scan tells us whether the host is up or down. If the target responds, you'll see ICMP or TCP responses, confirming that the system is reachable. Next is ICMP echo discovery. Nmap-PE target IP here. We check if the target responds to ping requests and whether ICMP is blocked by a firewall. TCP SYN ping on common web ports. Nmap-PS80 443 target IP. Even if ICMP is blocked, this method can still detect the host. We analyze responses to understand host availability. This approach is very useful when firewalls block traditional ping. TCP ACK ping to understand firewall behavior. Nmap-PA80 443 target IP. This helps us determine whether a stateful firewall is in place. These techniques help us understand host availability and firewall behavior before moving on to deeper scans. Best practice real-world approach is to combine multiple techniques. Nmap-SN-PE-PS80, 443-PA target IP. This is how host discovery is done in real environments, and it follows CEH and Red Team style methodology. Finally, if all ping methods are blocked, we use assume host alive mode. Command Nmap-PN target IP. This forces Nmap to continue scanning even when ICMP and TCP ping responses are completely blocked by a firewall. Understanding these techniques is critical because if host discovery fails, everything that follows will be inaccurate. Now we're using an AI-based analysis prompt without running any commands. This prompt is created to simulate Nmap host discovery results for a specific IP address. Nmap host discovery shows that IP is an active, alive host. The scan reports a very low latency of 0.00020 seconds, which indicates that the host is either very close on the network or highly reachable with good connectivity. Because the host responded to ICMP or TCP based probes, we can confidently confirm that the system is up and running. Based on the host name, this appears to be an AWS EC2 cloud server. At the host discovery level, the firewall does not fully block probing, but this does not mean that all ports are open. It only confirms that the host is alive. From a defensive cybersecurity perspective, this is normal and expected behavior for a public cloud server. We also gave the same prompt to Gemini CLI. Gemini CLI automatically generated the required commands, ran the scan on its own, and then displayed the results along with a full analysis. Here, we've shown only some common scanning techniques and commands. There are many more commands beyond these. As you keep practicing and working in real scenarios, you'll naturally learn which scan to use and when. Each scan type serves a different reconnaissance purpose. Choosing the right scan depends on visibility, risk level, and your objective. Stealth plus fragmented scan firewall. Evasion Nmap-SS-F target IP. This technique fragments packets into smaller pieces, making the scan harder to detect. It attempts to bypass simple firewalls and basic intrusion detection systems by reducing the chance of triggering security alerts. Decoy scan, source obfuscation, Nmap-S-S-D-RND:5 target IP. This scan adds multiple fake source IP addresses to the request. Its main purpose is to hide the real attacker's identity by mixing the true source IP with decoy traffic. Timing control, very slow and stealth. Nmap-SS-T one target IP. This option slows down the scan significantly to avoid triggering intrusion detection systems. It is used for low noise reconnaissance, making the scan much more stealthy and less noticeable. I'm not showing the full scan here because it takes a long time to complete. Scan with custom source, port nmap-ss- source port. 53 target IP scan uses a custom source port, specifically DNS port 53. It can sometimes bypass misconfigured firewalls that allow DNS traffic without strict filtering. Idle scan zombie scan, advanced command nmap-s izombie underscore IP target IP. This technique uses a third-party system known as a zombie to perform the scan indirectly. As a result, the target cannot easily determine who is actually scanning it. This is a highly advanced and rarely used scanning method. Full TCP port plus version plus scripts. Scan command nmap-p-s-s-v-s-c target IP. This scan checks all TCP ports on the target system. It detects running services and identifies their versions. It also runs default Nmap scripting engine scripts for basic vulnerability and configuration checks. This scan also takes a long time to complete, so I'm skipping it here. Vulnerability script scan, command nmap-script vuln target IP. This scan runs vulnerability detection scripts to check for known CVE. It also helps identify common misconfigurations on the target system. These scans run slowly, so for some of them, you'll need to be patient and allow extra time for completion. SSL TLS deep scan command nmap-script SSL enum ciphers -pip identifies weak or insecure SSL and TLS ciphers in use. It also helps evaluate HTTPS configuration and overall security hardening. Firewall detection and rules guessing, command nmap-s a target IP. This scan helps detect the presence of a firewall. It also determines whether ports are filtered or unfiltered based on the responses received. Banner grabbing, aggressive, command nmap-sv-version all target IP. This scan attempts to retrieve the maximum amount of banner information from running services. It is highly informative, but also risky, as it can be noisy and more easily detected by security systems. IPv4 plus tracer route recon, command nmap-a-tracer route target IP. This scan maps the network path to the target using tracer route. It also attempts to identify the operating system, running services, and routing information. Basic OS detection command nmap-o target IP. This scan attempts to identify the operating system running on the target host by analyzing TCP/IP stack behavior and response patterns. Here I've included some additional commands for OS discovery. You can either note them down or take a screenshot for reference. Make sure you always use your own authorized testing IP when performing these scans. There are many more ways to use Nmap for scanning. As you keep practicing, you'll naturally understand how these techniques work. My goal here was simply to give you a clear idea of what each scan does. During practice, make sure you do proper research on your own. That will make everything much easier. AI can help you analyze results and understand concepts, but it will never directly help you with hacking, and AI itself does not hack. It will only support you with what you need to learn. To get the best results from AI, you must use your own critical thinking. When you do that, AI can be extremely helpful. Just don't ask for anything harmful or unethical. Next class AI-powered recon, subdomains, tech stack, and target priority. Thanks for watching.